Hello, good evening.
Good evening, ma'am.
Yes, I think we should start. So, in the last class, I left question number 3. So, I'm going to start with that question today. Okay, so this is the question, which is just a minute. Yeah. So, refer to example 5, section 14.4, chapter 14. So, here is the example. I have just put the screenshot. Find the probability that a student of the class was born in August, right? So how will you do this question? Can anybody tell me? Okay, first of all, you require the total number of students, right?
Yes, ma'am.
So how many students are there?
Ma'am, 40.
40, which is also given in the question. Now you have to find the probability that the student was born in August. So you need to know how many students were born in August, first of all, right? So number of students born in August. Yes, how much, Mridula? Now you have to look at this, bar graph and tell me.
And 6 students.
6, yes. So therefore, probability, you can simply write P, or you can also write like this: probability that the student is born in August. So that is equal to 6 divided by 40. Yeah, you can reduce it to like 3 by 20, right?
Yes, ma'am.
Okay. All right. So next, I also left the question number 6 in the last class. This is the question. Now refer to this table 14.7. Find the probability that a student obtained less than 20% marks in mathematics test, right?
Yes, ma'am.
Okay, first, total number of students. How much?
Ma'am, 90.
90, which you can see in the table. Okay. Now, number of students who have obtained less than 20% of marks. Yes, how many students are there?
7.
7. Yes, Mridula, what do you say? Yes, Mridula. What are the number of students who have obtained less than 20% of marks?
Ma'am, 7.
7, yes, because this 20 is not counted here, right? So it is less than 20. So 7 students are there. Right. So therefore the probability, like in the first case, probability is equal to, you can write that the student has obtained 20% of marks. That is equal to 7 divided by 90. So it cannot be reduced further. Right?
Yes, ma'am.
Second part. Now find the probability that a student obtained marks 60 or above. So you need to tell me the number of students, first of all, who obtained marks 60 or above. Yes. So how many students are there? Tell me.
Ma'am, 23.
23. Okay. Mridula, what about you?
Ma'am, 23.
23. Yes, you are right. So basically this 60 will not be counted here. So we will not take this one. So 60 will be counted from here. So 15 students here, and or above means you have to also take the rest of the students. So 15 plus 8, right? 15 plus 8, which is equal to 23. So therefore, the probability becomes 23 divided by 90. All right?
Yes, ma'am.
Okay. Yeah, next. I think up to question number 7th we did. Now question number 8.
Seventh question.
7th question we have done. All right?
Yes, ma'am.
Okay. Question number 8. Yeah, this is the question. So here's the question. Okay, refer to question 2, exercise 14.2. So you have to refer to this question. What is the empirical probability that an engineer lives less than 7 kilometers from her place of work, right? So first write total number of engineers. How many engineers are there?
Ma'am, 40.
Yeah, it's given in the question, 40. Now first, so the engineers living less than 7 kilometers from her place of work. Tell me the number of engineers. Less than 7 kilometers from place of work. Yes, how many students are there? Oh, sorry, how many engineers are there? Now, see, when we did this question in the chapter of statistics, there we constructed a group frequency distribution table with the class size 5, right? So we took the table like this, 5 to 10, 10 to like 15, like that. Do you remember? With class size of 5, you have to take like this, or 0 to 5, right? So here, there is no need to make a distribution table because you have to take, look here carefully, you have to take less than 7 kilometers, right? And if you create a group distribution frequency table, so here 0 to 5 and 5 to 10. So how will you take less than 7 in this case? Yes, there's a problem. Yes, Hamna?
Yes, ma'am.
Yeah, so where will you stop, like 0 to 5 or 5 to 10? So you will do one thing, you will directly count from the data itself. You don't need to create a table. All right. Now see, number of engineers living less than 7 kilometers. So you just see in the data itself. This is less than 7, right? Less than 7. So similarly, you can count. So 7 you will not count because it is saying less than 7, right, Medula?
Yes, ma'am.
Okay, so all the 7 you will leave and all the less than 7 you will circle out.
Ma'am, 9.
Okay, let me finish. Oh, yes. Okay, so now count them 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. So there are 9. Yes. Now you can write then the probability that the engineer is living less than 7 kilometers from the place of work. It is equal to 9 and divided by 40. Right? You can reduce it to like 3 by, no, sorry. No, it cannot be reduced. Yeah, that's the probability. Okay, next, second part. Now, more than 7 kilometers from her place of work. Yes. How many are the number of engineers? Living more than, yes, who will tell me? More than 7 kilometers from place of work.
Ma'am, 31.
Okay, so have you counted from the data?
No, ma'am, 40 minus 9 would
Yes.
be 30.
Yes. Yes, Mridula?
Yes, ma'am.
Is she correct? Because he's in the question it is saying more than 7 kilometers from place of work. How many you got, Hamna? 31.
Yes, ma'am.
But I think 31 will. Okay, okay. It's saying more than or equal to 7. Yeah, fine. I missed out the equal to. Number of engineers living more than or equal to. Then it's fine. Yeah, so it will also include the 7 and obviously more than 7. So you don't need to count. You can simply subtract 40 minus 9 because this 9 was less than 7, right? So you will get the number of engineers who are equal to or more than 7, which is equal to 31. Is this clear, Medula?
Yes, ma'am.
Right. So the probability becomes 31 divided by 40. Right?
Yes, ma'am.
Okay. Next, third part. Now, within half kilometer from her place of work. So is there any engineer who is living within half kilometer? Within half kilometer from workplace. Yes. How many engineers are there?
Ma'am, 0.
0. Yes. In the data, the minimum distance is, I think, 2, right? So less than 2 kilometers, there is no engineer living. So less than half, 0. So the probability becomes 0 divided by 40, which is equal to 0. So there is no chance of any engineer who is living less than half kilometer. Right?
Yes, ma'am.
Okay, then now question number 9. See, question number 9 and 10 are simply activities in your book, right? I'm leaving those questions. I am coming to question number 11. Okay. Yes, this is question number 11. Now, 11 bags of wheat flour, each marked 5 kg, equally contain the following weight of the wheat flour in kg, right? So this is the weight 4.97, 5.05. So the actually the mark, sorry, the weight which is marked on the bag is 5 kg, but there is some up and down in the weight of the bag, right? So some are weighing less than 5, some are weighing more than 5, right? It's like that, a bit of less or more than 5. This is the data. Is this clear?
Yes, ma'am.
Okay. Now find the probability that any of these bags chosen at random contains more than 5 kg of flour. First of all, write total number of bags. Yes, how many bags are there? That you can count, right?
Ma'am,
1,
11.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now, number of bags containing more than 5 kg of wheat flour. How many bags are there?
Ma'am, 7.
More
Yes,
than
ma'am.
5
7.
kg flour. Okay. 7, fine. So the probability becomes that the bag contains more than 5 kg becomes 7 divided by 11. This is the answer. Yeah, just hold on. Just give me 1 minute. Yes. Next we come to question number 12. Just a minute, it has got hanged. Yes, this is the question. Yeah, in question 5, right? This is the question 5 of exercise 14.2. You were asked to prepare a frequency distribution table regarding the concentration of sulfur dioxide in the air in parts per million of a certain city for 30 days, right? Now, using this table, that means you have to use the frequency distribution table in this case. All right. Find the probability of the concentration of sulfur dioxide in the interval, this interval. So first of all, you have to create a frequency distribution table. Now, this was basically the original question. So we have to construct the table again. Then, yes, am I audible?
Yes, ma'am.
Okay, so in this interval, we have to find. Now, to construct a table, what we did, first write lowest value. What is the lowest value in the data? And highest value.
Ma'am, 0.01.
Okay, 0.01. And the highest value?
Ma'am, 0.22.
Okay, 0.22. Okay, now the class interval is, see, you can see from here, 0.16 minus 0.12. So what are you getting? 0.04 is the class interval, right? So you have to make your table like that. You will create a table like concentration of SO2, right? In parts per million ppm. Then you will make your tally and then number of days. All right. Now make your groups. So we will start with 0.00 to 0.04, right? Then 0.04 to next 0.08. 0.12, then 0.16, right? 0.16, then 0.20, right? Now 0.20 to 0.24. Now this much is enough because the highest value is 0.22. Now do the tally and then tell the number of days. Yes, Mridula, please complete the table and tell me. Yes, are you doing?
Yes, ma'am. Ma'am, done.
Okay, let her also finish. Okay, Hamna, you can tell me.
Ma'am, 4,
Hmm.
9,
Mm-hmm.
9,
Okay.
2, 4, 2.
2. Okay, so I'm just assuming you have done it correct. Next, what you have to find the probability of the concentration of SO2 in the interval 0.2 to 0.16, right? So you have to see this interval, this one. So you will write um, total number of days on which the data is collected. Sorry, for which the data is collected. Okay, so for how many days the data is collected? What is the total of these days? 30. It is also given in the question, right? 30 days.
Ma'am.
Okay. Now you have to count the number of days for which the concentration of SO2 lies in the interval 0.12 to 0.16. So how many days are there? 2. So the probability becomes the probability that the concentration of SO2 lies in between 0.12 to 0.16 on any day, right? So this becomes 2 divided by 30, which you can write 1 by 15. This is the probability. Yes, Mridula, is this correct? Yeah, I mean, is this clear?
Yes, ma'am.
Okay, please note it down. Yes, done. Okay, next question number 13. It is saying that in question 1, so this is the question 1, you were asked to prepare a frequency distribution table regarding the blood group of 30 students, right? Now use this table to determine the probability that a student of this class selected at random has blood group AB. Okay. First of all, you understand what does it mean selected at random? What do you understand by this term? Can anybody say? See, selected at random means that every student has an equal chance of getting selected. All right. It does not mean that some student is having a greater chance of being selected and some is having a lesser chance. No, every student is having an equal chance of getting selected. So in that case, we say that, the selection is done at a random. All right.
Yes, ma'am.
Okay. Now having the blood group AB. So this is the data. Now, first of all, you need total number of students. How many students are there in this data? Yes. How many students are there? 30.
30.
Yes. Now, number of students having blood group AB. So you can do one thing, you can create a frequency distribution table or you can just circle in the data itself. So one AB is here, right? Another AB is here. Then one more AB. Yes, only 3. So the probability becomes 3 by 30. Yes, you can reduce it to 1 by 10. Yeah, okay, one thing. Wait, you have to construct a table because it is saying that use this table, right? You see, read the question. You were asked to prepare a frequency distribution table, right? Then he's saying that use this table. So first of all, you have to create a frequency distribution table in this question. All right?
Yes, ma'am.
Or you may lose your marks if you will not create. So just create the table like blood group and then your tally and number of students or frequency. Right? So blood group you will take A, B, then you have O and you have AB. I think only 4 are there, right? And then you will do the tally and there you will find. So this way you will create a table first of all. And from the table you will see, you will get 3 here and then you can use this 3 here. Is this fine, Mridula?
Yes, ma'am.
Okay, so I'm not drawing the table. You can complete that. Okay, so this exercise is over. I just want to give you 1 or 2 questions for practice. That's it. And from tomorrow, I'll start the new chapter, which is construction. So I'm not going to start it today. Okay. Now, okay, I'm giving you this question and you will tell me the answer for this. Okay, just finish, do it in your copy and then I'll ask. Take your time. Yes, Hamna, how can you do this question? Yes, Mridula, any guess?
Ma'am, first we'll write the total number of families.
Very good, because you are selecting a family, right? So you require total number of families. Total number of families. How many families are there?
Ma'am, 1000.
1000, which is given. Okay, now first, that the probability, find the probability that it has no boy. What is the answer?
Ma'am, 240 divided by 1000.
Yes, good. So number of boys 0 are in 240 families, you have no boy, right? So probability is 240 divided by 1000. So you can just reduce it to lowest fraction. I'm leaving it. Second part, Hamna, you will tell me. One boy.
Ma'am, 560 divided by 1000.
Okay, very good. 560 divided by 1000. Okay. Then two boy. This is easy that you can see, right?
200 divided by 1000.
Good. 200 divided by 1000. Now tell me this one. At least one boy.
Ma'am, 560 divided by 1000.
Okay. Hamna, what about you? Yes. What will you say, Hamna?
Ma'am, 560 divided by 1000.
Now understand these two terms. These are important terms in the chapter of probability. What do you mean by at least and at most, right? At least means you should have minimum one boy, right? At least one boy has to be there. There can be more than one, but at least one has to be there, right? So you cannot take a family which do not have any boy. At least one boy has to be there. It can also have two boy. It can also have three boy. Do you understand? So in this case,
Yes, ma'am.
this means that the minimum number of boys should be one. So it means that at least means minimum number of boys should be one. So that means you also have to take the families which are having more than one boy, isn't it? So first of all, you will write number of families having at least one boy. So one boy is there in 560 families, and you also have to take 200 families because it will also be included in at least one boy. Yes, Mridula?
Yes, ma'am.
Okay, so this is the total number of families. So the probability will become 560 plus 200 divided by 1000. So you can complete the calculation. Now fifth part. So at most one boy, what does it mean? Now this means at most one boy means the maximum number of boy is one, right? It cannot have more than one. At most one, yani the maximum number of boy has to be one only. Now it can also have zero boy, but it can also have one boy. It cannot have two boys. Do you understand?
Yes, ma'am.
It means that the maximum number of boys should be one. So the number of families which are having at most one boy means you also have to take the number of families which are having zero boys and then which are having one boy. Is this clear?
Yes, ma'am.
Okay. and the probability will become 240 plus 560 and divided by 1000. Clear? Yeah, these terms are often used at least and at most, so you should understand these terms. Okay, one more question I want to give you. Now you will tell me the answer. Read the question properly. Yes, can you tell me what is the answer of the first part?
Ma'am, 210 upon 1000. 1000.
Yes, okay. See, okay, what are the total number of tires in this case? 1000, right? Yes, am I right?
Yes, ma'am.
Okay. Now, second, it will need to be replaced before it has covered 400 kilometer. So less than 400, that means this one, right? That means 210. So 210 divided by 1000. Okay. Second part, it will last more than 900 kilometer.
Ma'am, 385 plus 80 upon 1000.
Yes. Mridula?
Yes, ma'am.
See, more than 900 means you have to take like this also and this also. Both are more than 900. So 385 plus 80 and then divided by 1000. This is the probability. Now it will need to be replaced after it has covered somewhere between 400 and 1400. Now what will you do?
Ma'am, 325 plus 385 plus 80 upon 1000.
Why 80?
Ma'am,
It's going between. Ma'am, no, ma'am, they will not eat.
Yeah, in between 400. That means, see, 400 is not included here. It will start from here, right?
Yes, ma'am.
So from 400 to 1400 only. So that means only these two categories you have to take, right? So 325 plus 385 and divided by 1000. See, it's more than 1400, right? So you don't have to take 80. Now it will not need to be replaced at all. That means it has not covered any distance. There's no tire which has covered zero distance, isn't it? So you don't have any tire like that. It's 0 by 1000. Then it will need to be replaced, means it has covered like its full potential, more than 1400 kilometers. So you will just add all the numbers. What will you get here? Then you are going to get
Ma'am,
1000, right? So it's 1000 divided by 1000, which is equal to 1. Okay, I think last question. See, just for your a bit of your practice, that's it. I'm not taking a test. I just want you to answer me a few questions. That's it. Yeah, please answer this. See that you are finding the probability of bags, right? So you take total number of bags here. What are the total number of bags?
ma'am, 5.
5. The data is about 5 bags. Bag number 1, bag number 2, 3, 4, 5. So total number of bags are 5. Now, what is the probability of germination of more than 40 seeds in a bag? So how many bags are having more than 40 seeds?
Ma'am, 3.
3 bags only. No, more than 40. Okay, yeah, this 39. Yes, 48, 42, and 41. 3. Yes, good. So this becomes your 3 by 5. Okay. Now 49 seeds in a bag.
Ma'am, 0.
Yeah, there is no bag which is having 49 seeds. So 0 by 5, which is 0. More than 35 seeds in a bag?
Ma'am, 5.
5 by 5. All the bags are having more than 35. At least 40 seeds in a bag.
Ma'am, 4 out of 5.
No, at least means, okay, yes, I'm sorry. At least means minimum 40 has to be there. Yes. So you will just leave this one, and then all the bags are having at least 40 seeds. Yes, Mridula?
Yes, ma'am.
So 4 by 5, right? Now at most 40 seeds,
2 by 5.
2 bag. Yes, so at most means maximum 40. So this bag and bag number 1, so 2 by 5. Yes. So I think this much is enough for this chapter. I'm going to end the class, and tomorrow I'm going to start with the remaining chapter of construction. Is there any chapter left other than construction?
No, ma'am.
Yes. So other chapters are omitted by CBSE, the area of parallelogram, etc. All right, then let's meet tomorrow. I'm just winding up the class. Okay. Good night. Bye.
Thank you, ma'am.
Okay.